For the last few years, the basic idea behind an AI agent has been surprisingly simple. You give an AI a goal. It thinks, uses a tool, looks at what happened, and then repeats think, act, observe, think over and over again. This loop is behind a huge number of the AI agents we've seen so far, but something interesting is starting to happen. Developers are increasingly taking that single loop and breaking it apart. One AI plans, another researches, another writes code, another checks the code, and another decides whether the result is actually good enough. Instead of a loop, you get a graph. And this might sound like a small architectural change, but it represents a much bigger shift in how people are thinking about AI, because we're moving away from trying to build one incredibly capable AI employee and toward building something that looks much more like an AI organization. And recently, two of the biggest names in the agent ecosystem have been pushing directly into this idea. Andrew Ng has been arguing for specialized multi-agent workflows, and LangChain has begun building the infrastructure required to actually run these systems in production. So why are AI agents suddenly turning into graphs, and does adding more agents actually make them better? Or are we just recreating corporate bureaucracy with tokens? To understand the change, start with a conventional AI agent. Imagine asking one, build me a website that tracks cryptocurrency prices. The agent might decide it needs to inspect an API, then create the project, then write some code, then run it. Something breaks, so it reads the error, changes the code, runs it again, and continues until the task is finished. This is already dramatically more powerful than simply asking a language model for a block of code, because the model gets feedback from the environment. Andrew Ng has described this general idea through 4 important agentic design patterns. Reflection, the model looks at its own work and tries to improve it. Tool use, it can search the web, execute code, query databases, or interact with applications. Planning, it breaks a large goal into smaller steps. And finally, multi-agent collaboration. Multiple specialized agents work on different parts of the problem, and it's that last one where things become interesting. Because once you start combining these patterns, the simple loop doesn't stay simple for very long. Imagine asking one agent to build a substantial piece of software. It has to understand what you want, design the system, choose technologies, write the code, test the code, debug it, and decide whether the finished product actually satisfies the original request. That's a lot of context for one model to juggle. So instead, you split the job up. An architect decides what should be built. A tech lead converts that architecture into implementation tasks. Several developer agents work on those tasks, and a reviewer, or perhaps the user, checks the result. Now something strange happens. All of these agents might actually be running the same underlying model. They're not different because one AI went to architecture school and another studied JavaScript. They're different because each agent has a different role, different instructions, different context, and potentially different tools. Andrew Ng has compared this to hiring specialists inside a company, and he has discussed software workflows where specialized agents take roles like software engineer, product manager, designer, and QA engineer. It sounds almost too obvious. Humans divide complicated work between specialists. Why wouldn't AI? But here's the important bit. These agents don't necessarily run one after another. That would simply create a longer chain. Graphs allow the workflow to branch. 3 developers could investigate 3 solutions simultaneously. A researcher could gather information while another agent analyzes existing code. A reviewer could reject one branch, sending it back for another attempt while allowing another branch to continue. And a human can appear at specific checkpoints. This creates something much closer to a real workflow. Not prompt to answer, not even think, act, but plan, delegate, execute, inspect, retry, merge, ask human, continue. And this is essentially why frameworks like LangGraph exist. LangChain defines an agent very broadly as a system where a language model helps determine the control flow of an application. Once the AI controls which branch happens next, your workflow naturally starts looking like a graph. On a diagram, this looks fantastic. In production, it's a nightmare, because now imagine one of these agents runs for 40 minutes. Halfway through, a server crashes. What happens? Does the entire workflow restart? What did the other agents already finish? Which files should still exist? What did the system remember? What if it needs approval from a human who doesn't respond until tomorrow? What happens to the agent overnight? And what happens when one of your developer agents writes a Python program and then executes it? You probably don't want arbitrary AI-generated code running directly on your production infrastructure. This is the boring part of agents, and increasingly it's becoming the important part. This is where LangChain's latest move becomes interesting. The company introduced something called Managed Deep Agents. Deep Agents itself is an open source agent harness. It gives agents the ability to plan, use tools, write files, and delegate work to sub-agents. But LangChain noticed something. Building that behavior was no longer necessarily the hardest part. Operating it was so managed deep agents attempts to handle the infrastructure underneath, things like durable threads so a long-running task can survive, checkpointing so the agent can resume from an earlier state, streaming so applications can see what is happening, human in the loop controls so sensitive operations can require approval, persistent context so an agent doesn't completely forget its work between sessions, sandboxes so agents can execute code in isolated environments, and tracing so when your 11 agent masterpiece does something completely insane, you can hopefully figure out why. Managed deep agents was introduced in private beta, with the agent definition remaining in your own repository while Langsmith handles much of the runtime infrastructure, and that tells us something about where this industry is going. Hey, don't forget to like and subscribe for more like this. Now, back to the video. A chatbot can forget, an employee can't, or at least you hope they don't. Imagine an AI support agent dealing with a customer for 3 weeks. It needs to know what the customer already tried, which problems were resolved, what exceptions were granted, and potentially what previous conversations taught the system. LangChain's newer infrastructure is designed around preserving and managing the context agents need over time. That could include instruction, project information, operating procedures, research notes, or user preferences. And suddenly memory isn't simply chat history, it's part of the architecture. The graph now exists not only across agents but across time. And LangChain is pushing the idea one step further. It wants production traces to become part of the improvement loop. Imagine a customer service agent repeatedly misunderstanding the same company policy. Normally, an engineer has to notice, investigate the traces, change the prompt, deploy a new version, and wait. The newer generation of agent tooling is moving towards systems that can inspect agent behavior, find repeated failures, and propose improvements to the instructions and context the agent uses. The graph begins feeding back into itself. LangChain has described its broader agent development cycle as build, test, deploy, monitor, then repeat. This may turn out to be far more important than simply adding another model, because models are already extremely capable. The problem is getting them to behave reliably for thousands of real interactions. LangChain surveyed more than 1,300 people working with agents, and the numbers are revealing. 57% said their organizations already had agents in production, but the biggest obstacle wasn't token cost, it was quality. 32% identified quality as a major barrier to production. And look at what companies are doing about it. Nearly 89% had implemented some form of observability, but only around 52% were using evaluations. In other words, we're getting very good at watching agents fail. We're still figuring out how to systematically stop them failing. And this brings us to the uncomfortable part. If one AI agent can make a mistake, what happens when you connect 10 of them together? Every additional agent can add another model call, tool call, network request, context transfer, failure point, and bill. Multi-agent systems also introduce communication problems. Agent A might misunderstand Agent B. Agent B might produce the wrong information for Agent C. Agent C might confidently build on that mistake, and because language model failures don't always look like conventional software errors, the system might keep running. No crash, no exception, just the wrong answer. That's arguably more dangerous. Research into deep agent systems is increasingly showing that failures can happen across the entire trajectory of a task. Planning, memory, retrieval, delegation, and tool use. More intelligence doesn't automatically mean more reliability. Sometimes it simply means more places to go wrong. And here's perhaps the most interesting counterpoint to the entire trend. LangChain released Deep Agents 0.7. One of the headline changes? It reduced the base harness input tokens by roughly 65% at comparable performance. Think about what that means. At the exact moment the industry is building increasingly complicated agent systems, one of the major agent framework companies is also stripping complexity back out, because eventually more instructions, more context, more agents, and more orchestration become their own problem. The goal isn't to build the largest graph possible, it's to build the smallest graph that reliably completes the task. And interestingly, Andrew Ng has actually been warning about this. Despite being one of the strongest advocates for agentic workflows, he has repeatedly argued that businesses shouldn't immediately jump toward elaborate autonomous systems. There's still enormous value in simple, relatively linear workflows. Take a business process, break it into individual steps, automate the steps that AI can reliably perform, then gradually add autonomy, because if a 5-step workflow solves the problem, you don't need 17 agents holding a board meeting. And this is probably the part Twitter threads leave out. Graphs aren't replacing loops because graphs are automatically better. They're appearing because some tasks have become complicated enough that one loop is no longer enough. The first generation of AI agents look like this: one model, one loop, a few tools. The next generation is beginning to look very different. Planners, workers, reviewers, specialists, memory, sandboxes, evaluations, humans all connected through a graph. The model itself is becoming just one component inside a much larger system, and that might be the real shift. For years, the AI industry has been obsessed with making the model smarter, more parameters, more reasoning, more context, better benchmarks. But increasingly, developers are discovering that another question matters just as much. What happens if you take the intelligence you already have and organize it better? Humans discovered this thousands of years ago. One person can only do so much, so we created teams, specialists, managers, processes, checks and balances. And now, strangely enough, AI may be heading in exactly the same direction, except this time every employee might be the same model, just running a different prompt.